This is the 6th video in the series of species in solution, and in this video we'll be looking at weak bases. Points to note, which are very similar to the weak acids. Weak bases only partially dissociate, which means they only produce a few ions, which makes them weak electrolytes, and as a result they're going to be weak conductors as well. A good example of a weak base you should know is ammonia. So looking at the reaction of ammonia with water, we can see that it produces the ammonium ions and hydroxides. But you do need to be aware, like weak acids, the amount of ammonia is very high. Very few of the ammonia molecules actually dissociate, and so when you're listing the species present from highest to lowest, straight after water, you put your ammonia concentration, and this tells us that very few ammonias actually dissociate. Okay. The next thing we point out is that the ammonium ions and hydroxide ions get produced in a 1-to-1 ratio, and so their concentrations will be equal. Because we're producing a lot of hydroxide ions, the concentration of hydroxides will be considerably higher than the hydroniums. So the species present for a solution of ammonia, you've got your water concentration as the highest species, followed by ammonia. Your ammonium and hydroxide concentrations will be equal, and then you've got the very small amount of hydroniums. Let's look at that graphical representation. So in terms of graphical representation, the water bar is to the furthest to the left, followed by your ammonia. Notice that it's approximately the original concentration, just a little bit lower. Do not worry about these values here on the ammonium and hydroxide bars. You are not expected or wanting to guess those. It is just to ensure that the height of your ammonium and the height of your hydroxide bars are equal. And then you've got your small hydronium as a present to the right hand side. So that is the end of the weak base species present. Coming up in the next videos we'll be looking at the salts.